Going to talk to you briefly about using near infrared to keep crops alive. Because what's in the news today? Two big things that are in the news that are related but not immediately recognized as so are the global droughts. We're all hearing about all the drought situations and obviously the heat waves that you guys are having in Europe right now. And avocado toast, very popular, at least over here stateside. Things that with avocado are very, very popular. We have a chain called Panera Bread here. They just released a few salads with a bunch of avocados. So right now in the Western U.S., 40% of the Western U.S. this summer is in a moderate to extreme drought. So there's a lot of wildfires going on. So water management is something that people are looking at. And along with that is that the water intensive crops, like I mentioned, are getting very popular. So things like almonds, and we don't always think about this, that every almond, every little one that you eat took over a gallon of water to make that nut. And a single avocado takes 60 gallons of water. Think about how much water is in a 5-gallon bucket. And you need, 12 of those to be able to get an avocado. And cashews are up there too. Those are very popular. So you can kind of see here what the water demand is for some of these crops. And they get very notable in terms of when you scale that up over a large area. That's all to say that there's now a need for deeper insight into how water retention is working over that broader area when you're dealing with droughts and you're dealing with agriculture that needs more water than ever, but there's less water than ever. So how do you deal with that? So before we talk about the NIR stuff, I just want to do a quick overview on our spectroscopy. So our bread and butter are the broadband spectrometers. This is the EPIC group. So you all know this, but just in case maybe you're in another area of photonics and you don't know this, but our core spectrometers are basically a rainbow in a box. We send light in, it bounces off some mirrors, hits a diffraction grating, it splits it into all the rainbow of colors, all the wavelengths, that hits a detector array, and then the software converts that to just a signal so we can see how much energy we're getting at the different wavelength levels, right? So the benefits of this is that it's instant. You get it right away. It's literally the speed of light. Minimal sample prep. It's non-destructive, so you're not eating up sample when you're doing this. It's cost effective for the most part. You can do this stuff in little, sub $1,000 systems, and it's very versatile. So you can tune that rainbow to be in different areas of the spectrum. So obviously we see in the visible range. That's why it's called the visible range, the vis range here. But if you go past the violet, then you're in ultraviolet, right? So you can tune things to look at the UV, the ultraviolet. Then eventually you get into X-rays, you see through stuff, gamma rays, those turn you into the Hulk, the cosmic rays that are the background of the universe. And then you go the other way from the red, obviously you're in the infrared. And then you get into microwaves, cook your food, radar, AM, FM radio, broadband, all that stuff. So what we're going to look at here is the NIR bands, the near infrared bands that exist right around here for water detection. So what does that look like? There's in particular two big active bands at 1450 and 1950 nanometers. And you can get pretty affordable spectrometers that get up to 1700 nanometers because that's where the standard silicon and detectors will go, but then you can go out further for more expensive detectors. This was a set of data from a colleague of mine, Dr. Yvette Matley, and you probably have heard of her because she's really the face of ocean. She's been with ocean for a quarter century, literally. So she ran this study looking at different types of soils at different moisture levels. So you have dry sand at 4% moisture, topsoil that's kind of drier than most, and then premium soil that's a little submerged and that's higher moisture content, and then compost that of course is going to have a high level. And you can see these bands right at the 1450 and 1950 stacking up very coherently. So you're getting those signatures. And this gives you a clear differentiation of both the moisture level and the soil type. We're going to see that in some other wavelength ranges in the next plot on the other page there. But that's the whole idea, is that you can differentiate those moisture levels using these NIR bands very instantly and very accurately. And they're big. This isn't like we're using some sort of deconvolution to see this. This is just raw data right to the detector. You can see those stacks. So this is the type of setup you would be using to run that. where you have your light source, of course, obviously the spectrometer to make the reading, but then you're sending it through some fiber optic and trying to illuminate and then interrogate back up that light signal there. And then we use a reflection standard, in this case, a white standard there. But this is a typical desktop setup that you would use for this. But that's to say, we're trying to talk about this in terms of agricultural, right? So this is about deploying this for watching water retention, because when you have these different types of soils, when in an agricultural setting, you really have to be able to, over an area, you think about how big farms are, you have to be able to pull that data out in a realistic form factor. So what does that look like? You can do that with a handheld device where you're do more spot checking. Maybe it's a smaller area like a research farm where you're not really trying to cover huge areas, and you can do more of a handheld system that's pretty easy to do. The towers are actually popular. This is a real tower in an agricultural setting that uses our equipment in there. And you can see on the, if you're, you can see here, all the different, these are fiber ports pointing at different angles out. So there's like down, and then you can see like, 5 o'clock, 4 o'clock, 3 o'clock, all going through here. And you can also see, you see this black thing up top here? That's one that's pointing up to the sun, because in the prior one, we were using a light source here, right? So we're forcing the light ourselves. In an agricultural setting, you're almost always going to be using the sun as your light source. So to track that and understand what the sun is doing, and as your source, you can have one pointed up like this black antenna that has a fiber. It's looking at the solar illumination, and then down at the crops, and then you're getting that feedback up into the fiber and the spectrometer. So that's great for continuous monitoring and for fixed locations. Obviously, you're not moving the tower around. But if you want to move around, then you have the drones. And they do make these. I mean, we make an near infrared spectrometer, a small one like this, that can go on, and many other folks do. I don't want it to sound like a commercial, but like, because you can get this from all sorts of suppliers that go on drones, and now you get this top-down view of everything, and you can move that around very efficiently over larger areas. So that's good for like mid-sized farms and whatnot. And then satellite is the next way up, right? You can see how we're stacking this up. We go from handheld to a fixed tower to a drone up into a satellite there. And then when you're using a satellite and you're looking at other bands, that's where you're able to see the different types of environments that you're looking at. So whether you're looking at just surface water or a forest or grassland, desert, plains, all these different things, that's where you're going to get those signatures that are going to tell you what type of ground you're looking at, or water for that matter. And then if you're looking at ground, what that moisture content is using those NIR bands that we talked about. So this was just a quick snapshot. Hopefully I didn't, yeah, so 8 minutes, 8.5 minutes. Quick snapshot of how you can look at water in different form factors in an agricultural setting using these near infrared spectrometers. So thank you so much if there's any questions.